Okay, welcome to the notes on solving inequalities. Hopefully we remember this from Algebra 1 also, because this is review. It might be a little bit more complicated, or it might just be a little bit of foggy in your memory, but we'll try and brush you up so you are caught up and ready to go. So we're going to solve and graph inequalities, and we're going to write and solve compound inequalities, and we'll get to what those are in a second. There's an MP3 player anymore that looks like that. It's ridiculous. Okay. Let's see. Essential understanding. Some things that essential means things that we gotta know. Words like at most or at least, these are like the keywords in a word problem that are going to clue you into an inequality may be a part of the problem. So just some basic reminder stuff, and this is stuff you guys know. If it's x is greater than 4, there it is as a word sentence, and on the graph, greater than, that's where we have the hollowed out version of the whole, of the, the dot on the number. X is greater than or equal to, that's where we're going to fill that in. That's the big difference there. And then same thing for less than or equal to, okay? 4 is the boundary point. It separates the graph of the inequality from the rest of the number line. And then it talks about open dot and closed dot, and that we talked about already. So let's take a look at problem number 1, writing an inequality from a sentence. So first thing we need to do is just be able to write this out. This is the same thing we did with equations, where you're going to have to take a sentence and then translate it numerically. So fewer is that indicates subtraction. Don't confuse that with the inequality. 5 fewer than a number is at least. There's the part right there. That indicates, and ironically, at least indicates greater than or equal to. If we don't, sometimes it doesn't make sense to us right away because we say, well, least, that means least, that means less. But actually, like if I say I ate at least 7 donuts, okay, that means I had 7 or more, all right? So that's how we get this inequality right there. So x, 5 fewer than the number is at least 12. So x minus 5 is greater than or equal to 12. Which inequality represents the sentence, the quotient of a number in 3 is no more than 15. The quotient of a number in 3 is no more than a number than 15. Go ahead and pause the video, try that one, and then unpause, and I'll tell you. Okay, so you've unpaused. The quotient of a number in 3, so hopefully you have x over 3, and then we have 15, and then the question becomes, which inequality do I put in here? And it's actually less than or equal to. Okay, the quotient of a number in 3 is no more than 15, so it could be 15, but it can't be greater than 15. It has to be less than or equal to 15. All right. The solutions of an inequality are the numbers that make it true. So solving inequalities is a lot like solving equations. You see a lot of the same properties, things that we've seen. Really just what we do to one side we have to do to another. The big key is that when we, and you guys may remember, when we divide or multiply by a negative, we have to switch the sign. Here's how that works, okay? Let's see. We have a is greater than b, so we subtract b from both sides. So now over here is 0. We can rearrange that to be negative b minus a negative a, and then add negative a to both sides, and we end up with negative a is less than negative b. All this is doing, this is a proof essentially to show you that when we multiply or divide by a negative, the inequality switches sides, or switches directions. Okay, that's important. Writing that down would be a good idea. Okay, simple, and you've been doing it for a long time, but something that we definitely have to know. Okay, so when we multiply or divide by a negative, the inequality switches directions. We got that. You like the handwriting switch there. I know. I'm impressed too, to be honest. Okay, so let's take a look at an example here. So solve and graph. So we're going to solve it, and then we're going to graph it on the number line. Okay, so no problem. Here we distribute the negative 3, we combine like terms, we get x by itself, we had to divide by a negative, so you notice the switch right here that took place, and then we're going to graph that on a number line. For your number lines, guys, you don't have to do all these numbers. I'm fine if you give me a number on either side, and I'll show you what I mean by that in a second. All right? Take a second, try number 2, and see if you get the same thing as me. Go ahead and pause the video here and try number 2. Okay, so you've unpaused, and here's my answer. I subtracted 5 from both sides, then I divided both sides by negative 2, then I subtracted both sides by negative 9, and I got x is less than or equal to negative 8. Now, you may have done different steps, but if you got the same number, then we're good to go. Then up here, I graphed it. This is what I mean as far as your number line. I just need the number that we're starting at, and then a number on each side, and then is it filled in or hollow, and then which direction it goes. A really easy way to check your answer here is pick a number that fits into this inequality. So if we chose negative 10, plug negative 10 in and see what happens. So negative 10 right there. That becomes negative 1. Negative 2 times negative 1 is 2. 2 plus 5 is 7, and 7 is greater than or equal to 3. So it worked. So you can check your answers just by plugging stuff in. Let's take a look at problem number 3. Problem number 3 is a word problem, but same idea. A movie rental company offers 2 subscription plans. You can pay $36 a month and rent as many as you want, or $15 a month and $1.50 per movie. How many movies must you rent in a month for the first plan to cost less than the second plan? So we need an expression for each one. So the first plan is just 36, no problem. That's an easy expression. N is the number of movies in a month. The second one is 15 plus 1.5n, and then we want the second one to be worth our while, so to speak, so we make that greater than. We want to rent more movies that month. And then we subtract 15, and we divide by 1.5, and we get n is greater than 14. No problem. Okay? So let's take a look at number 3. See if you can come up with the variables. Sorry, jumping all over the place here. Seeing if you can come up with the variables and an expression and an answer. Okay, pause the video now. Okay, so here's my setup. I got $9 and then plus 1D. I didn't write the 1, but it's $1 per download. And we want that to be greater than $25 plus 0.5D. All right, so the first thing I'm going to do is I'm going to try and get my variables on one side and my numbers on the other. So in doing that, what I did, and I know I didn't show my work here, but what I did was I subtracted 9 from both sides. Here, there we go. So I subtracted 9 from both sides, which is how I got 16, and I subtracted 0.5d from both sides, which is how I got 0.5d over here. Then I multiplied both sides by 2, and I got 1D is greater than 32. So how many songs must you download for the second plan to cost less than the first plan? You got to download at least 32. 32. Obviously, that person does not know that Pandora is a thing. All right. Problem 4, no solution or all real numbers as solutions. These are the always, sometimes, never, same things we did with equations, and it's the same rules, except for if you get an inequality that is false, it has no solution, so it's never true. If you get an inequality, like down here, the inequality negative 15 is less than or equal to 8 is true, so that is always true, and it's all real numbers. No problem there. Take a look at number 4. Pause the video, try number 4, and see if you get always, sometimes, or never. Okay, so I'll walk you through this one. You've unpaused. This is 8x minus 12 is less than 8x plus 8. If I subtract 8x from both sides, I get negative 12 is less than 8, and that is always true. All right? You can join two inequalities with the word and or the word or to form a compound inequality. To solve a compound inequality containing and, you find all the values of the variable that make both inequalities true. So for example, down here, we have 7 is less than 2x plus 1, and there's a huge difference between and or, so we want to make sure we recognize that, highlight it, do whatever you got to do. And is different, okay? And essentially, I like this over here. You find the intersection of the two graphs, okay? So we solve each one. We get x is greater than 3, so that's this one right here. and then we get x is less than or equal to 6, and that's this one right here. And our answer is this part down here in purple, okay? Our answer is this purple part down here where they intersect. That is the answer, all right? So find a way to make note of that. That is your answer, okay? So let's take a look at number 5. What is the solution of 5 is less than or equal to 3x minus 1 and 2x is less than 12? So you can pause the video and work on your own. I'm going to go ahead and start working this problem now so people can I can walk you through it, and then if you do this one, if I do this one for you, then you can go ahead and do the next one on your own. So let's see, we have 5 is less than or equal to 3x minus 1. So we have 5, we'll add 1 to both sides. So we have 6 is less than or equal to 3x, and so we have x is greater than or equal to 2. Over here, we just divide both sides by 2, and we get x is less than 6. Okay, let me add a couple marks in here to our number lines so we can have all the numbers we need. So let's go right here. We have x is greater than or equal to 2. So let's label this 0, 1, 2, 3, 4, 5, 6. Greater than or equal to 2 gives me that going forever this way, right? Less than 6 gives me this going that way. So my answer is the combination of those two. My answer is actually a solid filled in marker there, an empty one there, and the line in between them. Those are the values that will make that inequality true. All right. And then part B, is the compound inequality in problem 5 always, sometimes, or never true? Always, sometimes, or never true? And the answer there is sometimes, okay? It's sometimes, because it's true when x equals 5, and not true when x equals 7. Okay? So it's true when x equals 5, that's an equals, goodness gracious. That's an equals, and not true when x equals 7. So it's sometimes true. Let's take a look at the next example. We just did and, so you can we can collapse. Oh, sorry, one more thing on that. You can collapse a compound inequality. So if we have 5 is less than x plus 1 and x plus 1 is less than 13, we can write it just as one inequality. 5 is less than x plus 1 is less than 13. Okay? Or you could read that in the reverse. You could say x plus 1 is greater than 5 and less than 13. To solve a compound inequality containing or, that's a little bit different. We're going to find all the values that make at least one of them true. So same thing, we solve each one, but you'll notice on this one we have x is greater than or equal to negative 1, so that's filled in and it's going forever that way. And then we have k is less than negative 5, so that's hollow and it's going that way. And that is the answer. They're both the answer. So it could be any of those values. None of these values in here will make the inequality work. All right. So let's take a look at number 6. I would suggest pause the video here. Try number 6 on your own. See what you can get. Okay, pause the video here. Okay, so you've unpaused. Here's the answers I got over here. W is greater than 8/7, and W is less than negative 3. So let's take a look at my answers here. W is greater than 8/7. Well, 8/7 is slightly more than 1. So we'll say that's right there, and that's open, and it's going forever in that direction. And less than negative 3, also open and going forever in that direction. And that's it. That's all you got to do. Over here at part B, I have x is less than negative 1, so right here, and going forever in that direction. And then greater than 3, open, and going forever in that direction. And that's it, guys. Easy stuff there. Hopefully you remember all that stuff from inequalities. And don't worry about the lesson check. I just flipped to that. I know. We'll do that. We'll look at that in class together. But that's it for the notes. Thanks a lot. See you next time. Bye.